So today we're going to work on some momentum and impulse problems. Recall that when you're talking about momentum, we have some object that's going to have some mass associated with it. So we have to have an object, and if there is an object, there is mass with it. All right, so that mass, it has to be moving. If this box right here has some mass and it's not moving, there is no momentum. All right, momentum is that property of a moving object. So this box has to be moving with a certain velocity in order for it to have some momentum. All right, so this is our formula that we're going to use. We're going to say mass times velocity equals momentum. All right, the first part here, we need to make sure that you understand I give you all of the answers on the paper. They're all there. So what are you responsible for? You're responsible for showing the work to get that answer. All right. So beginning with question 1 here, it says, what is the momentum of a 3 kilogram object? So for number 1, we're going to have our 3 kilograms. We're going to fill this in. See, mass 3 kilograms. We're going to say that this object is moving at 5 meters per second. So we're going to go times 5 meter per second. If you leave the units of measurement off, you get no credit. So make sure you put it in there. And we don't need a calculator for this. We know that 3 times 5 is going to be 15. And then our unit of measurement for this is going to be kilogram meter per second. All right? It doesn't get any easier than that. So what you have to do is you have to do that same thing for the first 5 problems. You need to show the setups on how we get these different answers. Do not put the squiggle line in. You fill in the information. And you put in what your correct values are going to be for the answer when you calculate those momenta. Let's go to the second part here. The second part, what happens if we have a change in momentum? So the box from earlier, it's moving, all right? So we have mass. You have a certain velocity associated with this. But what happens if all of a sudden this box that's moving at 10 meter per second, all right, and its mass is 10 kilograms, so we have 100 kilogram meter per second for its momenta. What happens if the box now stops? All right, so this box stops. What would its momentum be now? Well, you would have mass. You'd have our velocity. The mass would not have changed, but the velocity would have changed. So our momentum now is 0 kilogram meter per second. So what is that delta P, that change in momentum? Well, it was 100. Now it is 0. So our change in momentum, we've decreased by 100 kilogram meter per second. All right, so we've decreased that. So you could put maybe a negative in here. So we know that it's a loss of. So for our problems, we have to alter our formula just a little bit because now we're having to figure out our change in momentum. And that change in momentum, well, that change occurred because we had a differing velocity. The mass stayed the same, but the velocity is changing. So for the formula here, we're going to just simply put momentum, change in momentum, right? Because we have a altering momentum with this, equals mass times, and then we'd have in that delta V for our change in velocity. Another way that we would have this change in velocity would be if we'd say our final velocity minus our original velocity. Okay? So our calculations here, we're going to use that slight variation in our formula to calculate for the differing velocities. So for question 6 here, question 6, it says, what is the change in momentum of a 3 kilogram object? All right, so we have 3 kilograms, that's the mass, times. I said it's going to accelerate from rest to 12. Well, we have to figure out if it's accelerating from rest, that's the original, so the 12 must be the final. So we're going to say final minus original. You've got 3 times 12. You're going to have 36 kilogram meter per second. All right, so that's how we're going to answer these for questions 6 through 10. All right, so you'll have to fill in all of your information for each one of these, just as we did before, and then you check your answers with what I give you on the piece of paper. This change in momentum that's occurring. We have a change in momentum because our velocity is changing, so our property of that moving object changes. The momentum changes. What we need to figure out is what causes that change in momentum. If you're in a car and you're changing your velocity, well, a force has to be applied. And that force being applied through a period of time is what we call impulse. All right, so impulse is changing the momentum. All right, so when we have that change in momentum, we know that the mass of our car or person or whatever is going to be changing velocity, and that change in momentum is impulse. That impulse was caused by a force being applied onto the object through a period of time. All right, so for number 11, we're going to use that concept, and it says, what is the impulse of a 3 kilogram object? Well, 3 kilograms, that fits right here. So I'm going to put 3 kilograms. It says it's accelerated from rest to 12 meter per second. So I'm going to go times. Well, a change in velocity, that's this guy. So 12 meter per second minus 0 meter per second. It says, what is the impulse? Well, here is our equal sign. Here is the impulse. And what you should notice is that this answer, when we type this out, it comes out to be 36 kilogram meter per second. So what was our impulse? The impulse is equal to our change in momentum. So it's the exact same idea. All right, now, one thing I will point out is that the impulse might have differing units of measurement. So I put down kilogram meter per second because that's the units that were used right here and right here. But recall, I said just a moment ago that it could equal force times time. So we could technically say 36 Newton seconds. These two units are going to give us, or those two values, the units might differ, but the quantity, what we're trying to describe, remains the same. All right. So you will use that idea, that formula, to help answer questions 12 through 15. Okay. You fill them out just as we did before, checking your answers with the paper that I provided you. We're going to go on to question 16 now. I'm going to cheat a little bit. I'm going to grab this right here because we're not going to change that. That's a formula. We're not going to change the formula. So we're going to use that formula, just making sure that's nice and clean here for you to see this. It says for 16, we have how much force. Well, force, that's this thing right here, right? So I'm going to put F because I don't know what that force is. It says how much force is there? It says how much force is exerted on a 3 kilogram object. Well, kilograms, that identifies mass. So I'll put in 3 kilograms right here. How much force is exerted on 3 kilogram object to accelerate it from rest? Okay, well, that's change in velocity here, right? So we're going to have 12 meter per second. It says from rest, so that would be the original. And the last part of this, it says from rest to 12 meters per second in a time of 1.5 seconds. So I'm going to put in 1.5 seconds right here. Why? Because that's where the time is at. All right, now you're going to notice all I did is I matched up units to portions within the formula. All right, we know what the left-hand side is. That's 36 kilogram meter per second. On the right-hand side, you'd have 1.5 seconds times your F. To get rid of that, you have to divide both sides by 1.5. So I believe, I'm going to cheat here. It should be like 45 something maybe. We have 36 divided by 1.5. Oh, whoa, I was going the wrong way. Should be 24. So the force of this should be 24 newtons. Okay, and then we check our answer on the paper, and sure enough, 24 is my answer. Okay, it's always good to double check ourselves, right? We're going to follow that same process for 17 through 20. And again, you have to show the work in order to get credit. And you do want to make sure that you punch those numbers into the calculator, so that way you know you're doing it correctly. All right, let's go to the last set of questions that you're going to have for today for this work. For number 22, here, it is going to use that same set of formulas. We're not changing anything. It says how much time is needed. So time is the question mark. Now, I don't know what this is, so I'm going to put in T. I'm not going to put a question mark in. I'm going to put the variable T in here. It says to accelerate a 3 kilogram object, well, that's mass, 3 kilograms. From rest to 12, well, that's a change in velocity. So we have to go with final minus original. So it says from rest to 12, so 12 meter per second minus 0 meter per second. And it says this time, if there is a force, so number 22, if there is a force of 2.5 newtons. So 2.5 newtons, hold on, let me give this a little more room here. So 2.5 newtons times our time. All right, well, we know the left-hand side, that's going to be 36 kilogram meter per second. On the right-hand side, you have, to get rid of that 2.5, so if you have 2.5 newtons times your time, we have to divide both sides by that 2.5, right? So if we divide both sides by that 2.5, we should come up with 14.4. And since we're looking at units of measurement here, since you're dividing both sides by newtons, divide both sides by newtons, we come up with our final unit here is going to be for time. So our unit of time used in this is seconds. So 14.4 seconds is what we'll have. What you'll need to do is use that same formula and work your way through to number 26. Again, filling in all of your work right here, and then double checking your answer that you get in your calculator with what you have provided to you on the answer key over here. All right. If you don't fill in units of measurement, if you don't show your work, you don't get any credit. All right. We're working on the process of solving the problems, not necessarily stressing out over what the correct answers are. All right. I'd rather have you learn how to do this more than focusing on trying to get every single one of them correct. We have to learn the process first. Okay. So when you're finished with these, make sure that you put your name up at the top of your paper and then submit that. Take pictures of it and submit it to Schoology. Okay? All right. If you have any questions, make sure that you try to get a hold of me. If we're back in school, just come up and ask me and I'll help you out with it. Or if we're still in the remote status, then make sure that you email me or hop into a Zoom session with me. Okay? All right. Take care.